Okay, Bismillah Rahman Rahim, Assalamu alaikum, and today we'll talk about radians and how we use it instead of degrees, which is the more common thing as you progress within mathematics. So, first of all, what's a radian? Let's define what radian is. Let's say we have a circle and we form an arc along the circumference of the circle such that it has the same length as the radius of the circle. So, the angle which is formed here will be 1 radian. Let me repeat. If I were to, let me just draw it roughly. Let's say I have a circle. Here's the center. If I were to take any piece of this arc or like along the circumference of the circle, which is equivalent to the radius, because obviously from the center to any point in the circumference is the radius. Let's say this is R, this is R, and this is obviously R. And the arc formed has the same length as the radius of the circle. The angle which is formed here is 1 radian. So that's the definition of it. So now if I were to go and see some extra definitions of the radian, here's just a formal definition I wrote. The radian is an angle formed by an arc equivalent to the circle's radius, and we could see that 2 pi radian is equal to 360 degrees. So that means 180 degrees is equal to 1 pi radian. And we could use this to convert between radians and degrees by using this ratio. So for example, if I want to find theta, I could just multiply example x degrees times pi all over 180, and also vice versa. And we're going to see, I'm going to write down a few examples on how we could use this ratio to convert between radians and degrees. And let me stress on something. Since we're going to be using a calculator, obviously within our solving, please make sure of what type of mode your calculator is set on, either degrees or radians. To shift between them, or like to actually change between whether you want to work with radians or degrees, go to your calculator, press shift, and then mode, which is right next to the on and off button. I mean the on button, my apologies, and you'll see that 3 and 4, 3 is for degrees, 4 is for radians. And please keep it on 4, please. And also don't forget to switch back whenever you're working with other questions which don't really require radians. So let's solve this question. Convert the following angles from radians to degrees, and we have two radian degrees, radian angles, apologies, 5 pi over 4 and 3 pi over 2. So what I'll do is use this ratio as a sense of like comparison, so I could convert from radians to degrees. So let's do it. So let's solve A. A is 5 pi over 4, so we have pi is equivalent to 180, or this is the ratio between them. And I'm trying to find x, which is basically the degree, like the angle but in degrees. And we have 5 pi over 4. We're trying to find x. So cross multiplication, of course. So we have x is equal to 5 pi over 4 times 180 all over pi. So either way, the pi's will cancel out, you know. But obviously, let's just input all this in the calculator. We have 5 pi over 4 times 180 all over pi. So this is equivalent to 225 degrees. You can obviously do it without the calculator since the pi's will cancel out. 180 divided by 4 is 45, so you're doing 5 times 45, and that's basically it. Let's move on to the second. So we have the same point of comparison. We have pi equivalent to 180, trying to look for x degrees, and we have 3 pi over 2. So x is equal to 3 pi over 2, 180 all over pi. You can see that the pi's will cancel out. 180 times half is 90, so 3 times 90. So that's equal to 270. Let's just make sure. Yes, it is. So this is equal to 270 degrees. So this is how you can convert from radians to degrees. And obviously, if you want to do the vice versa of it, from degrees to radians, you'll follow the same steps. You'll use the ratio as a point of comparison, and you'll just do cross multiplication. Okay, so next concept we have is how to find the length of an arc. So obviously this is the arc that we're referring to, or this basically. So the formula is basically you multiply the radius and the angle which is created by the very same arc. And obviously this angle is theta, and theta has to be in radian, please. Theta has to be in radius. So this is the formula. It's very simple, nothing too confusing. The length of the arc is equal to the radius multiplied by the angle in radian. So let's say we have this example. We could say we have this shape, or a part of a circle, where the radius is 7, theta is given by 0.35 radian, and we're asked to find the length of the arc. So very simple, we'll just apply the formula. Length equals radius times theta, or the angle. So that's equal to 7 times 0.35, and that's equal to 2.45 meters. So we have the length of the arc is equal to 2.45 meters. Okay, so let's solve a question based on also the formula of the length of the arc. And this is a question we have. We have a triangle. You can see we have like a part of a circle enclosed around the triangle of radius 2 meters. What just happened? 1 second. Okay, apologies for the misinput. Yeah. So we have radius 2, and we have an angle theta. We have the center, and the length, and you can see the base length of here and here is 2.4, and asked to find length C, which is basically the arc length around this triangle. So what we could do, of course, is that we know that the length of an arc is basically r times theta. But the thing is, with theta, you cannot instantaneously find it. We have to first of all find this, and then subtract it by 2 pi, because either way is a whole revolution or a whole circle will be of 2 pi radian. So I can just subtract it off of that. We'll be left with the actual length, the actual angle of theta, and then we could input or plug it into the formula for the length of an arc. But first of all, to find this angle, and let's just name it, you can name it phi. Why not? Let's just name it phi. So the way we could find phi is through the cosine rule, which states 2.4 squared. I'll just go straight in, like with the numbers, equals 2 squared plus 2 squared minus 2 squared, because it either way it will be 2 times itself twice. And you could say cosine phi. And phi obviously will have to be in radians. So before we do so, we have to make sure that our calculator is set in the mode of radian. And if we do that, we could find that phi is equal to cosine inverse. We can just open a bracket here. 2.4 squared minus 2 squared minus 2 squared all over negative 2 times 2 squared. And this in radian will equal to, give me a moment. So up to 3 significant figures, this will be of 1.29 radian. So we could now say that phi is equal to 1.29 radian, and let's subtract it by 2 pi radian, so we could find the total. So we could find what theta will equal to. So therefore 2 pi minus 1.29, and let's calculate that. So theta is approximately equal to 4.9961, and then many other values after that. And to be honest, for me, I'll just round it up to 5, just for the sake of simplicity of calculating. Please don't do that in the exam. Please use the actual values you get, like just use the result you get from the calculator. But I just want to show you how to do it. But the numbers, obviously, just use what's exactly. So this is equal to 5 radian, and that's equal to theta. So we have both the radius and theta now. So we have r times theta, which is equal to 2 times 5, and it's approximately 10 meters. Okay, next question. We have this like sector of a circle where we have two regions, one unshaded, one shaded. And in the first question, we're asked to find the parameter of the shaded region when theta, basically the angle subtended from, let's say, this center of the sector we have here, or the circle that we took apart from, when theta is equal to 0.8 radian. So first of all, how to approach this question? Let's first of all define what parameter means. As we all know, like parameter is just basically the sum of all the edges or all the sides that give the enclosing to a geometric figure. So let's say a square. So the sum up of all these sides. It's what causes the closure of the geometric figure, or to have a closed shape. So if we were to look at the shaded region, we have this arc, and we have two lines here, and then we have another arc. So the arc here is 2 meters. So we have 2 and 2, and we have, let's say, arc 1, and just name it L1, and arc 2, L2. So the way we could find these arcs is basically, obviously, using the formula that we discussed before. The length of an arc is equal to the radius times theta. So in here, we have this arc, which is created by a radius of 3 meters here, and obviously the angle which is subtended is 0.8. So let's first of all sum up everything. So we have P, which is basically the parameters, equal to 4 plus 2 plus 2 plus 3 times 0.8 for the first arc, plus the second arc, which we have here, or let me go to the original drawing, the big one here, and it's caused by a radii of 5 meters, because the sum of these two. So it will basically be 5 times 0.8 plus 5 times 0.8. So that will be equal to 10.4 meters. Second question states is find the angle, or the measure of the angle, obviously in radian, when the parameter of the shaded region itself is 14 meters. So we already know the formula to calculate the parameter. So all we'll do is just find theta. So we'll have the parameter, which is equal to 14, is equal to 4, as we know. The shaded region is the one we're calculating, 4 plus 3 theta plus 5 theta. Gather the like terms, obviously, and we could subtract 4 from each side. So we'll be left with 10 equals 8 theta. So we'll be left with 10 over 8 is equal to theta, or in other words, 1.25 radian. Okay, next concept we have is area of sectors and segments. And what we start off is sector. So basically, sector is what we were talking about this whole time. It's just a part of a circle that's cut out by the like two points from the circumference drawn to the center, and the part that you're left with, which is all of this, is basically its sector. So to find the area of this, it's calculated by this formula: r squared theta over 2, or just half times r squared times theta, and obviously theta being in radian. So yeah, that's the area of a sector. So let's just solve a quick question on it so we could grasp it even further. So let's say we have the area of this of AOB. So it's basically being this sector where the angle subtended from the center to the 2 points on the circumference is 0.8 radian. The area is 28.9 meters squared, and we're asked to find R. So what we could do is just, since we know the formula, it's half R squared times theta. So what we could do is just, we're just finding the value of R. So we have 28.9 equals R squared theta over 2. It's sent to the other side, so 28.9 times 2, that's equal to 57.8. I could have easily calculated that, but the blessing of a calculator, like, because I'm in uni, so most of my mathematics weren't even, like, no calculators were not even allowed, be it calculus or linear algebra, just no calculators allowed. Don't know why. So yeah, 57.8 is equal to R squared theta. And we have theta as 0.8 here, 0.8. So R is going to equal to, and obviously we're going to only, since with squaring, you can take the positive or negative, but here obviously you're going to take positive only. Give me a minute, what the hell just happened? So yeah, as I was saying, we're only going to take the positive. So in the end, R is going to equal to root 57.8 over 0.8. So that's going to equal to 8.5. 8.5 meters. So yeah, that's how you use the, like, glitch in the recording. So yeah, that's how you use the formula for the area of a sector to calculate this question. And moving onward, we're going to talk about area of a segment, and I will just demonstrate it right now visually. So what a segment is basically, let's say we do still have the sector, however, let's say we only draw out the sector, and here's the arc. If we were to connect the 2 points on the circumference which create the sector, like this, the 2 points, excuse me, as I said, the 2 points on the circumference, which are these, if we were to connect them with a straight line, so this part is called the segment. And the formula to find this area is obviously, if you look at it geometrically, what you're doing is just basically taking a part of the sector. So what you do is calculate the entire area, which is half R squared theta. And this part should be removed such that we could find the area of this segment. And it's basically a triangle. So the formula of a triangle is, for the area, is half. And since we're dealing with a circle, so this is R and R, obviously. So it's going to be R squared and then sine theta. You could take common, or we could take half R squared as the common factor, and this is the final form of the area of a segment. Half R squared times theta minus sine theta. So let's solve a question based on the area of segments, and here we're asked to find the area of the shaded region. So keep in mind, the area of the shaded region is the entire circle except that sector. So the way you could find the area of the shaded region is by obviously calculating the entire area of the circle and then subtracting the area of the sector. So we have the area of the circle, which is pi, and then the radius, which we have given here as 1.2. So pi r squared, 1.2 squared, minus the area of the sector, which, sorry, as you mentioned, it's half 1.2 squared, half r squared, and theta being pi over 5. So let's calculate that, and we're asked to leave this in terms of pi if it's appropriate to. So let's continue simplifying this even further. So 1.2 squared is 1.44. So we have 1.44 pi minus half of that is 0.72. So 0.72 times pi over 5. Let's see if we could somehow calculate this and see whether it's going to be like a rational number or not. It's going to equal 1.44 in the end, so we could write that as pi. Take pi as a common factor. 1.44 minus 0.144. So that would probably be, and we can just leave it at like that. We don't even need to. So we know that this is going to be the area itself of the circle minus the sector. Next question, we have this circle where we have this part shaded and this triangle shaded, and what's unshaded is this segment. So what we're going to do is going to calculate the area of the circle and then subtract from it this this segment. So we're going to calculate the area of the circle, then subtract from the area this part of the circle, aka the segment, such that we'll be left with everything but this. So area of the circle is obviously pi r squared, so we have 36 pi minus, and then we already know that the area of the segment is half r squared, so 36 times half is 18 if I'm not mistaken, so we have 18. Theta, what's theta? 7 pi over 4. So we have 7 pi over 4 minus sine 7 pi over 4. So if we were to simplify that, it will be 36 pi minus 18 times, so we'll have 7 pi over 4, and the sine value of this is, it's actually negative root 2 over 2, so negatives will cancel out each other, so we'll be left positive 2 root 2 over 2. So let's simplify this even further. So we have 36 pi minus 18 times 7 pi over 4. That's basically 63 over 2 pi. 63, just say 63 pi over 2 minus, apologize, I made a mistake. I wrote an extra 2 here. It's supposed to just root 2 over 2. So that times 18 will be, that will just be 9 root 2. Yeah. We'll probably take pi out together. But yeah, we have everything in terms of pi minus 9 root 2, so it doesn't matter. We can just leave it as this. So the area of this shaded region, or the circle just minus this segment, will be along this value.